Hi guys, this time um, I'm gonna try to solve medium problem and um, with higher priority frequency and also with a high acceptance rate. So if I solve this with acceptance rate, the sum has 90%, and so the reason is that some of the medium questions are very difficult, and then um, okay, and then I wonder whether um, I try to solve these problems step by step from easier one to the difficult one. So although this one has very high acceptance rate, but I'll try to solve this one because it has higher frequency. So 1K 137 dot product of two sparse vector. Given two sparse vector, compute their dot product. Implement sparse vector. Sparse vector num initializes the object with the vector num. Dot print. Compute the dot product between instance of sparse vector and VAC. The sparse vector, a sparse vector is a vector that has, okay, let me set the timer to 60 minutes. Sparse vector is a vector that has mostly zero value. You should store the sparse vector efficiently and compute the dot product between two sparse vectors. So here, follow up. What if only one of the vectors is sparse? Num1, num2, 1, 0, 0, 3, 0, 0, 2, 4, 3, 0 equals 8. So it says that efficiently, store sparse vector efficiently, because num1 length equals num2 length. The length is like this much. Value is under 100. So one thing we can do is let's say that only this one is not 0. Then the index is I. So in the case we can only store this value. So first thing we can think is but the thing is when we I'm thinking like if we store this value and this value, and then in here for the, so this is I, K, J, K. In that case, we can go through from here. Well, the order is not very important, so pick anyone. Well, probably this can be picked first. And then we can see whether vector B has case index. If it has, we can multiply. And then moving on to this one, we can see whether vector B has this value. Since it does not have, we'll ignore, right? So to do this, I think the best, the good way of storing vector is hash. It's the map. So sparse vector private map. So the first one is index and the second one is value. So let's call it M. So here for int I equals 0, I nums size I plus plus M if nums I not 0, so what we should do is mi nums I, right? And then dot product here. So when, since this is a class, is 0, that is non-zero, int I. So m dot find I, not in case of non-zero, we should have this, right? So this is non-zero, and then we'll need bool val, get val I, so return, but we should mi must exist. So in real product, we can add some if statement or assert statement to check this, but let's skip this from here. So this is mi. So here, for const pair int pair from n, inside the n, m. So we have index pair and then this is not pair with p, and then value. So we'll get this, and then if vec dot is non-zero index, then we'll have product which is 0 initially, because if everything is 0, then the answer must be 0, so we'll return product at the end, right? And as far as vector, vect is a perpendicular. This is sparse vector, right? Oh, vec non-zero. Then what should we do? Then count product equals p dot second vec get val, right? So, and then we'll return product. So this one is pretty easy. Dot product to sparse vector. So so the minimum size is 1. So we can make some cascades. So first one is 0, and then second one is 0. This could be the 1, or something like this, or something like this, or now we have some very low one, and then some very low one. So this from here, 0, since everything is 0, m will be empty. So we might want, so well here this for loop will not be called, so 0 will be returned. In case of this one, also same. If this one is this object, then it will have 1 element, and then in case of non-zero, we will add, but this case is 0, so we will not add, right? So yeah, I think this will work. Wrong answer? What? So 0, 1, 2, 3. 0, 1, 2, 3. Not 0. We'll add this one. So from here, product plus equal. It is this one, right? Why is output 2? So p second is Hopefully that would. Mhm. What? Oh, this seems like it's always 2. Why? Maybe I use. Hmm, I don't. I don't want to do this, but I really don't. I thought that this is very easy one, but here, um, I don't know why it has the. So, index, and then get value. Mm. So 0, 1, 3, 2, 4, 3. Vector, oops, is this 3, 1? What? Why is this 3, 1? And then 1, 3, 1, 4. 1, 3, 1, 4. No, 3, 4. So here, this is the, for this is 3, 4. And this is 3, 2. And then inside the loop, 1, 2, which is 3, 2. But this is not, why 3, 1? Oh, maybe, why is it 1? Why is it, why is it 1? Hmm? So, oh, whoa, gosh. Ah, oh, okay, okay. So I think this is it. There might be some other way to solve this. But, well, not bad. This is 2 to 3 3. Memory wise. Let's run this several times and let's see how this will change. Worse, better, yeah. Um, 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 we don't, yeah, we don't, so we, yeah, but this is reference. So this num might not be, so one way to solve this is, we can also, if num will not be changed outside, we can keep this reference, and then in that way, and then we may not use we may not use a vector. So what first vector this, okay. Mm, um so let's what I want to do is here we just do v dot nums, but we are not sure whether this will work because um nums vector int, we are not sure whether this will work or not because there is no such word in the question. And then here what we can do is we can loop in here. So for int I equals 0, I v dot size, and then I plus plus if Now, if vi is not 0, vi is 0, then continue. And if vi is 0, then if let's remove this, then let's make it public. Public is not a good way, but p dot I is 0, continue. So here, now let vi 0 is not 0, and maybe you could use this not 0 and not 0. What we can do is product equals vi multiply fact, and then int 0, and then turn product. I'm not sure whether this works. Yeah, maybe the value of vi is somehow changed, so this will not be the, this is some kind of other way around is we can use set, but it is also similar. We might be able to, we may want to use unordered map. This one is a little bit fast. Unordered map, because this one does not sort. So in case of map, it sorts everything, so insertion is a little bit slow to keep the tree sorted. Well, let's see, by changing this, speed is getting a little bit faster, and then memory speed is a little bit better. Okay, let's finish here. So I did some dumping, but the time is, I spent like 27 minutes, which is not a which is good thing. Okay. Bye.